everybody, and Angela, thank you for inviting me today. So I'm happy to be here. And I will talk about the project that we have done in Chicago. It's a case study. It's a residential development by the lake waterfront. You can see here on the map the general location. So you can see the Chicago and the Lake Michigan. We are like right on the lake waterfront in the downtown area. In the close-up map, you can see this little red dot, the exact actual project site. Just south of the Chicago River, mouth into the Lake Michigan. And it's part of this Lakeshore East neighborhood. You can see to the upper right the boundaries of the project site, part of this Lakeshore East master plan. It's basically connecting this Lakeshore East neighborhood and the broader downtown neighborhood, that vicinity, to the Chicago lakefront. The original plan development master plan intended for these tall high-rises to have this tall building frontage at the perimeter of the site. The context around the site, you can see here a couple of photos. There is the multi-level roadways of the Lakeshore Drive to the east and the Wacker Drive to the north, lining the property. You can see this is a very dense urban environment with a lot of towers around, and the site is lined on all these other sides with a 5-story tall service podium of the neighbors. And here's a couple of photos of how it looks today. So you can see these glassy towers and in this urban landscape park on top of the podium for more shots, and a view also from the Lake Michigan. So we'll go over in next few slides over the project considerations taken into account through the design process. So we'll go over design, performance, and testing goals and requirements to be achieved for the project. For the design, we'll touch upon the site planning, tower placement, views, form and aesthetic, and the layout of the exterior wall. Performance-wise, we'll go over the facade material selections and considerations, energy performance, wind and acoustic analysis, and bird-friendly design strategies. And then at the end about the weather performance testing. So the proposed plan development places these 3 towers into a landscape podium with this cascading park that connects the neighborhood on multiple roadway and pedestrian levels, with the pedestrian and bicycle paths underneath the Lakeshore Drive to the lake. You can see here that we, in our tower placement, we have broken away from the grid of the city that you can see basically omnipresent around in the neighborhood. And this was part of our design strategy to, first of all, be good neighbors. This is very dense urban environment, a lot of high-rises. We wanted to maintain these view corridors for neighboring buildings, and at the same time, we wanted to also maximize the view opportunities for the users of the future users of this development. So you can see extensive studies on in this aspect. As far as the design goes for the aesthetic and the form of the development, we were looking for having these glassy towers embedded into this 5-story earthy podium that is fully landscaped and ties the whole development together. The verticality of the towers is further reinforced with these vertical accent spandrel panel strips that run by the sides of each of these towers. Before going to this, I will just mention what you see in the image here and what you see in our plan development layout is showing 3 towers. At this phase of the construction of this development, 2 of them are built. This is the Cascade and the Cirrus, the 2 of them to the south. And the one that is further northeast in that corner is the tallest and slated for the future construction. So breaking away from the grid in the layout of the towers allowed us also this further looks and consideration into breaking away from the rectangular form of the body of the towers. So you can see it's a curvilinear shape. And this was all part of these strategies for optimizing the views. In addition to that, we have used the serrated facade layout to maximize the view opportunities for the future tenants of the buildings. This serrated design is further rationalized for this unitized window wall system itself through the use of modularity of different configurations to reduce the number of these unique angled profiles, which would give us better control in production of the system, installation, and weather control. The materiality of the whole development was, took a lot of studies, but I'll focus here more on the glazed facade of the towers, which you can see highlighted in this light blue color. A lot of these different glass types that are addressing different requirements in different locations of the development of the project. So for this, we had to take into account visual qualities of the products that we were analyzing and considering for the project, as well as the performance requirements that were needed to be met. So from visual side, we were looking at the reflectivity of the glass, transparency, color and the tint, flatness of the glass, while at the same time, all those qualities had to be cross-matched against the requirements of the energy and performance, the low-E coatings, the different kind of considerations for acoustical performance at specific locations, the laminated glass waviness, that's something that we were studying a lot. And then finally also the bird-friendly design. And in this photo, just tagging across between these 2 different towers, all of these different glass types, so you can understand that there is different performance requirements. Yet we were maintaining that cohesive visual quality of the towers. So some are unique to each tower, and some of these materials are basically coming across between both towers. The percentage of the vision glass of the tower was about 65%, which we were able to achieve through careful energy modeling and considerations for the orientations of the facade. And at the same time, we were implementing the LEED sustainability requirements for design of the project, achieving the LEED gold level certification. For the wind tunnel analysis, other than the ones that are done for structural considerations of the towers themselves, we performed the ones for cladding of the building, so that the cladding can be engineered efficiently and to the anticipated design wind loads that are specific to the local context. But in addition to that, we also did analysis for the pedestrian comfort level. In this kind of a densely built environment, a lot of these winds can get fairly high and uncomfortable, creating some uncomfortable hotspots as they get funneled between these tall towers. So we identified those locations, and through these analyses, we're able to mitigate such conditions by strategically recessing certain portions within the towers, at the entries, providing landscaping configurations that were needed, and the windbreak screens. You saw in those initial slides that this development is really, this project site is flanked by those really high traffic roadways, and for that reason we performed acoustic analysis for the site itself. Literally took like sound testing equipment to a boom arm on a cherry lift in the middle of the site and left it there for a week to look at and understand the daily cycles and weekly cycles on the different noise levels and noise frequencies that are happening at the site. And then took that information into acoustical simulation for the towers themselves, which informed us of the locations where we would need to consider acoustical performance glass for specific outside-inside transmission class levels, performance levels to be mitigated. Finally, for bird-friendly design, we had a lot of considerations talking to American Bird Conservancy Society on requirements to mitigate the death of birds. So you can see in a lot of areas where there's glass buildings built, birds cannot visually perceive that it's something they cannot fly through. And you can see a lot of dead birds around some of these buildings. So we're placing this ceramic threaded glass grid on surface number 2 of the panels that are in vicinity of these landscaped areas, and especially some locations where we have both indoor and outdoor landscaping. And then through conversation and the dialogue with that organization, we also learned that the serrated form of the facade, though it cannot be scientifically calculated, but it does perform better, and it's more bird-friendly design than the simply broadly faced glass surfaces and broad-faced planes of the towers that are easy to confuse the birds. For weather performance testing, we had a performance mock-up unit built in a facility, and took it through rigorous testing procedures over more than 30 steps, taking into considerations items from operable vents that we have on the residential project, the accessibility requirements, and of course the structural loads, deflections, interstory drift, and horizontal vertical movement of these stack joints, as well as thermal cycling, etc. After the performance mock-up testing has passed, then the exterior wall was taken into production, and then during the construction, we had multiple field tests performed at each phase of the construction to ensure that the weather-tight envelope was delivered. And then here is a couple of more shots of the final condition and what it looks like now. Thank you, guys.